Hello, today we're going to draw a polygon on our PlayStation Portable. I loaded up the Hello World program. There's another video on how to create this Hello program, how to load it up to the PlayStation. So go and look at that if you want to know what all of this stuff does. We're also going to use OpenGL, and I have a full playlist on OpenGL, spec 1.2, because that's what's running on the PlayStation. So you can go and look at that also. So yes, now we start with live coding. We're just going to start from here. So we have our emulator, and this has PlayStation scrolling around there. We want to draw some graphics on it. So let's just comment out everything that has with the drawing of the text. And now we have nothing. And if you remember OpenGL, we had the initialize method. Can't spell it today. We had the initialize method, and then we had a few glute display function, keyboard function, things like that. We don't have that here. So in this while, we just need to call our display function that we haven't coded yet. And we can get rid of how to compile, because I already set up in this project how to compile it, so just ignore that. Don't need that, don't need that. We need a void, initialize. We're going to fill with some data, and we need a display, we need to fill with some data. Let me start the program for drawing on the screen. There we go. Has it started? It has started, okay. So the first we're going to do is define our screen. And our screen width on and PlayStation Portable is 480. Oops. Screen height is 272, I believe. And then we will need something called a buffer width. But I'm just going to set to 512 without telling you why. Now we go into initialize, and we're going to initialize this. Let me guess, that's how we do it. Now we have initialized the graphic utility library. We can use that. In OpenGL we had GL begin and GL end with GL polygons, I believe, or was it triangles? Anyhow, we do not have that here, but you will see that these two systems are very similar. So we have SCE, GU start, and then we have GU direct, and then we need to send in a list, and then we have finish as an end. So that's our begin and end, more or less, not totally, but more or less. So we need this list, and this list object is a reference to a memory list. So we actually got a place in memory. That's our list. Point to that one. This list will be filled in with operations, and when we do our OpenGL stuff, we draw things, it will actually be stored into this list. So one call will be stored there, and the next call will be stored in memory, and so on. So when we draw our scene, it will be stored in memory only. Then at some point we're going to say, okay, it's done. You can send all of this down to the GPU. So it just takes this list and send it down to the GPU, and the GPU executes the list. This makes it so we can execute this list multiple times. So we can send down the commands to the GPU at multiple times. That means we don't have overhead of actually setting up the calls and executing the calls. Anyhow, let's create that list. It needs to be aligned on 16-bit boundary, which means if we have our memory and we have, where is it, byte boundary? Anyhow, it needs to be aligned at 16 bits. So if that is 0, this is 16. I have a camera in my way there, so I can see if I touch 16s or not. So it has to start. Here is fine to start. There is fine to start. 32 would be over here. 24 here. That's all fine places to start. This would not be a fine place to start. That would get us into trouble. Probably a segmentation fault. We do not want that. So I selected an unsigned int. Int happens to be 4 bytes. 4 bytes happens to be on the line of 16. It's actually on 32. Each 32 and int can be put in, but anyhow, that's going to be aligned on 16. So let's see, how did I get out from the drawing tool? There we go. And this is the space where we want to store our, let's call it OpenGL calls and arguments. Then we're going to send down to the graphic unit, so the GPU. But before we do that, we need to set up our video memory. Because if you have a computer, you have a specific memory in the GPU for video RAM. That doesn't really work here. You have to tell the PlayStation what memory to use for what. So we're going to just call it the video memory, start as address 0, because why not? Then we need this display RAM, and I'm just going to say that the display is going to start at the start of the video RAM. And then we need a draw RAM, could be the double buffering here then. Or we will use double buffering, so we will need a draw RAM. So we're going to have buffer, and we're going to draw in that one. And at some point we're going to send it over to the display. So 2 different places in memory, and we're just going to put them in, let's see, there we got green, so we got our memory. And we're going to put the display first, and we're going to put the buffer after that. So, and we will call the function that just swaps those 2. Or not swaps in memory, but swap the address in the GPU, and it will read from the correct space. Anyhow, we need to define the size of this draw RAM, or more correctly, we need to define the size of the display RAM, and the next address after that is our draw RAM. Got our display RAM plus buffer width times screen height times 4, because we have that's our size of the color. We got the red, green, and alpha. That's 4. So we used buffer width here instead of screen width. And when we have our buffer allocated, say that's the size of it, but the true screen width is actually just this. So we allocated more buffer, this part, than we needed for the screen, this part, and that's just to make it simpler for the logic for the PlayStation, since it wants to work with something. Oops, that was wrong. Wait, because it wants to work with those kind of numbers. So 2 raised to some power, and that happens to be that one, but since our screen width isn't raised to 2 to some power, then we need to just set the buffer width, and that means we're going to have unused space in memory. But that is fine. So now we have our video RAM that happens to start at 0 for just because why not? And then we set our display to start at the same position at 0, and our draw RAM starts at display RAM plus buffer width plus screen width times 4. So now we need to provide this information to the framework, and we will do it. So I think we need to do it in between those start and finish here. So let's see what they are called. This buffer, I would guess. And it needs the size, and in this case it needs the screen size. Width, screen height, display RAM, and it needs the buffer width. And then we have the draw buffer, and that's the same size, so we don't need to specify that. But we do need to specify how the pixels are stored, and that's why we have a 4 here. Because I'm going to specify 888, which is 8-bit, 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 and 8-bit. This is 4 bytes. Did I say bit or bytes there? I meant bytes. So here we got the color, alpha, red, green, and blue. All of those are 8 bits. We're going to specify that. I'm going to specify the place in memory, and we're still going to specify the width for buffer width for some reason. It's the same as before, so you could guess it isn't necessary, but it is. Let's see, what do I need more? I need is it called that? That's our viewport, if you remember. Doesn't matter, where the OpenGL has a viewport, and PlayStation has the screen, and you can tell PlayStation that I want only to draw things that fits in a specific area in the screen and not the rest of the screen. And that could be if you have a menu on the side and you just want to draw in the middle. So we're just going to specify 0, 0, and we're going to specify screen width, screen height. Let's try to compile it, see if I got that stuff correct or not. It complains, so let's include the header files for this. That's graphic unit or utility, graphic utility. And we're going to include the GUM also, that's graphic utility. I don't know what M stands for. It's kind of the glute version of PlayStation. See if that's fine. Undefined reference, could it be called glue? Yep. Okay, so far we got like nowhere, but anyhow, after we're done with our list here, we're going to sync it. In some cases it seems to work without syncing it, but I'm going to cold sync anyhow. And then we're going to swap buffers. I wonder if that's actually the GUM. It's not the GUM, it's the that one. Yep, it is. But before we're going to swap buffers, we're going to data build. No, that's the display. Display weight vertical blank. Wonder if there's any parameters for that one. No. And I gone through vertical blank in the hello world. So you got two videos. You got how to compile for PlayStation. I think maybe just one video and a hello world in the same. Yeah, I think that's just one video. How to compile and make a hello world. Okay, so what do we have now? We have started the list that we're going to send down to the GPU. We send it down there. We specify direct. We have three different modes so that you can specify that you're going to send down the information directly to the GPU, or you can just store it in the list, and that's why you have memory list. And you can just call upon the list later. And then you can, from a list, call another list. And that's the three different versions. The direct, just create a list and call it. I think that's called do send, when you just send down the list to GPU or you do not call it. And then you have third version, which escaped my mind, when you can call a list from a list. Now let's see, we set up the display buffer, draw buffer, the sister, we enabled it. There is some stuff missing here. Let's ignore that. Hope doesn't matter. I have to debug that later. We jump into the display, and the display going to do the same thing. It's going to work on the list, and it's going to send down that. Going to finish, sync it, wait for the display vertical buff, display weight vertical blank. Now swap the buffers. In here, now it would be good if you have looked at the OpenGL playlist and the matrix. We're going to do matrix mode. We're going to select the matrix mode. We're going to select the viewport, the view, and we're going to select the projection. That's also in the other video, and model is also in that video. And for all of them, it's going to load identity. That's also in the OpenGL matrix video. So that's what we're going to do. And we're not going to do anything really under projection. In the other one, we set a field of view. So we have this cone that you have your eye here, and you're looking down this cone, so to speak. And you have a field of view here, so you got 90 degrees, very easy to see. And you had the distance to a near plane, and you had the distance to a far plane, and you could draw objects in the middle here. And if we were outside of this, you couldn't see them. So if you draw them here or there, you couldn't see them, and you need to draw them within the viewable distance. That's this part here. Anyhow, in that other video, I said that you could specify a FOV by just the distance to the screen and how big the screen is. We're not going to do this in this case. We're going to specify the angle. And let's see, I think it's GUM perspective. We're going to have 90 degrees. And we're going to have 16:9 display. So we have a ratio on the display. On the OpenGL we used before, we specified the size of the display. We're not going to do that now. Here we're just going to say that this is 16 and this is 9. But it isn't. We know the true values on that one. That's that. But that's 16:9, I hope. So we're just going to set the ratio we want, and we're going to set the near plane and the far plane. So in this case, draw it again. This time we have specified the angle. We have specified, it's hard to draw this because I need to draw it in 3D in this case, but we have the display here. And the width and height, we have specified a fraction between them. And then after that we have established the near plane and the far plane. There we go. And now we just need to draw our object. And when I draw a cube, I believe, or was it? No, first I draw a cube with GL begin and GL vertex, 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 GL end. And in a later video, I was drawing with a draw array. That's what we're going to use now. There is no GL vertex begin end really. So GL GU draw array, and we're going to draw triangles. Going to draw triangles. Now let's think here. We're going to draw color 888. Getting to Y. We're going to draw vertex 32-bit float. Believe that's how it's done. And GU transform 3D. I believe that's how it's done. How many vertices we're going to draw? We're going to draw 3 of them. And we will not use indexes, and we will send down our vertices. So we haven't defined what we should draw yet, but we defined a name for it. And what's in this we haven't defined yet. It has to be a color in it, and that's the size of the color. So that's alpha RGB, 8 bits each of them. The vertexes should be 32-bit float. That's just a float in C. And we're going to send this data through the transform hardware. We can also send it through just to 2D, which wouldn't go through the matrix things in the PlayStation. Which means that the PlayStation actually a really good 2D machine, not just 3D. And when I'm thinking about that, we have forgotten to define the screen here. Maybe I should define the screen. It's called viewport, and it's called offset, I believe. And the viewport is odd. Parameters to this command is odd. So the PlayStation has a screen, and let's see if I can scroll up a bit so I can get some more gray area. Here we got the screen of the PlayStation, and this one is 4096. This is a virtual screen, not a physical screen. A physical screen, we have the information here, right? And it's the same this direction, 4K, so 4096. And then we define a screen, viewable screen here. That one, that's 480 to 72, that we're going to display. And we can scroll this around, so we can move it and display something, some other place. From the virtual screen, we can display on the screen, so to speak. So we take the information at some place, we say, this place I want to display that, and we can tell the systems, I want to display that part in the memory. But now we're going to display this first one. And that's why I'm saying that the PlayStation Portable is actually a really great 2D machine. But that's not so strange when you think about it, because I mean, it came out in the 2D era. I mean, it was one of the first 3D consoles, so handheld at least. So we're going to say that our offset in the screen is 0, 0. We start at the top left. And we're going to say that the viewport, and this is someone please fix this. But I know they can't do that. The framework is what the framework is, but it defines the middle of the screen and then the size of the screen. So we're saying, oh, okay, we got the memory area and we're going to display there, and we're going to display something of this size. So why they couldn't say like, hey, we're going to display from there to there, but no, we're going to specify that we need to display the middle and the size of it. Confusing, yes. I've done that. Let's go back to our 3D object. So on the PlayStation, you have to define yourself what you want to display. It's kind of like we did in draw arrays when we included texture coordinates or not texture coordinate. So let's display a vertex or created vertex, how we want to store it. I want to now assign the int because that's going to be a line on 16. And it happens to be also the size of the color I selected on here. So probably a reason why it needs to be aligned on 16, to be honest. And now we need a few vertices. Was that spelled correctly? No, it was not. And I'm word blind, so there we go. And we're going to specify the color first in reverse order for some reason. I noticed that the PlayStation like its values in reverse order. So that's R. And then we're going to use green and blue also later. So red first. And we're going to specify that at static position we're going to use. Let's see if I remember. Correctly? Is that how you draw a triangle? Just going to color the different corners different there. So we have at 0, 1, which should be up there, and -1 is just -1 here. So it's going to push the polygon from us, so it goes into the viewable area. We could translate it later, but we are just going to type it into the actual polygon here. So we got the screen that's like this, and 0, 1 should be up there. Then we go to 1, 1, that should be down there, and then we go to 1, -1. That's not correct. Yeah, I forgot the minus there and there. So let's see now. We have red at that position up there. Then we got red, green. We got green at 1, -1. That's there. And then let's see, do I have a blue here? Yeah. And we got that one to -1, -1. So 0, 0 is in the middle of the screen, right? Exactly like OpenGL. Oh, I think that is correct for my vertices. Yep. And we could define a texture here also, but we want to try texture right now. So I defined my vertices. And now everything should work, and we should get the polygon drawn on our screen, which won't happen because it will be a bug somewhere. I need to debug it, but let's see if I, for some reason, did everything correctly. I did not. So first of all, implicit declaration of matrix mode, which I do not believe. Could it be like that's in the GUM header? Could be, because it didn't complain. and apparently it wasn't called transform. There we go, and it didn't display anything. So let me debug it a little bit and I get back to you. Okay, so I have debugged it and I found 2 errors. I rolled back my debugging, but I got 1 error up in the initialize, and I got another error down in the display, and I forgot something about also, but not totally bug. But initialize, I need to set graphic utility display to true, else apparently we do not display anything on the PlayStation. I mean, why would you have a handheld console without displaying anything? But fine, I set it to true. And down here, the give draw array, I couldn't get it to work, but there's a same method in the other header file, so let's add a M to it and hope that works. And now we got our polygon here. It's all in blue. It shouldn't be all in blue. It's also a bit wrong here. If you look at it again, it's not oriented as I drew it. And that's because I flipped that one. I thought. Could it be the clockwise, anti-clockwise? So let's set front face to GU clockwise. Front face, is it that? Okay, maybe roll that back for now. Let's figure that out later. At least it displays, so that command is correct. But it displays as just blue and it should have different colors. And that's the shading mode, so we need to set that. So interpolate smooth between the different, don't you call it like that? Shade mode. Yeah, that was easy. It's shade model, not mode. So there we go. Just need to move that green point down there. And that should be that. So let's see. What do we have here really? Got 0, 1. Wait a minute now. There we go. That looks much better. Because that should be our polygon. And it starts as 0, 1, 1, -1, and -1, -1. Like I drew it in the start, but apparently I ain't clever enough to type down what I'm thinking. And there we go. Now we got our polygon. Now let's transfer it over to our PlayStation. Let's see if it's possible to see the PlayStation now. Let's start that. Go up to USB connection. Wait on Windows. And I got the sound on Windows. And it takes forever. There we go. Now on our PlayStation, we go to game, we go to hello. We're going to replace that one. I need a new window. And okay. Let's see. Yeah, I'm looking off screen here. Workspace, build, bin. There we go. That's our build. That looks fine to me. Close down everything. Close down that. Exit out here. And now something more will happen because I set up the build environment in my ID. So I got icons also for this hello world. They shouldn't be there. They just happen to be copied from my game here. So ignore that, the first one is hello world. We start it and let's hope we got a polygon showing. And there we go, we have our polygon displayed. It's a little bit hard to see the colors. I can see them fine, but the camera can't see them. It's the lighting here in here, and that camera isn't the best one, to be honest. But there you have a polygon. I'll quit out. So now you can draw a polygon on PlayStation, which means you are very close to making games on it. See you and good luck.